Welcome back everyone. Hope everyone is fine and keeping safe. Here we are going to do the AWS training track 4, that's for VPC. So let's get right into it. Before going forward, let's check out a few of the network basics. So whenever we try to connect to the World Wide Web, the internet, how we do that is through ISP or Internet Service Provider. Now, how we get that connection done is from the ISP, you have a particular IP that is given to you. So that would be your public IP. So if you go ahead and type the public IP in your URL, what's my IP, you will get your public IP, which is visible to everyone. So that is what the router gets, and this is actually translated to your particular machine. Now your machine will have a private IP. So sometimes you will find an IP whenever you do IP config or something like that. You will actually find out that your IP is of the range of say 10 dot or 192.168 range. So these are ranges of private IPs. So there is a translation that happens. So when you type in what's my IP, you'll see a totally different IP. Now that's a public IP. Now how the public IP and the private, translates to the private IP is what is called NATing. Now let's see what are the terms that we need to know here. So first of all, it's the IP or Internet Protocol address, which is basically the IP, which is an identifying address. Now, like I said, so there is a public IP that you have. Now that is for the ISP to know what device it is connecting to. And it's not an identifier for the particular device per se, but it is it's an address provided by the ISP to that device. It is not the not who that particular device is. Okay, and similarly in the case of a private IP, so the 192 range IPs or the 10 dot range IPs, now those IPs are actually what you can provide your devices. So those are actually the addresses you are providing to those devices. So it can be either to DHCP. I'm not going to go deep into DHCP or how you give it separately. So manually you can give it. So I'm not going to get into that, but that is the IP address. Now the MAC address, on the other hand, which is media access control address, that is what defines that. So every machine which accesses the internet, that will be assigned a particular MAC address. Now MAC addresses are like fingerprints for those devices. For example, so if there is a MAC address for the router, that would be specific for that particular router. On the other hand, if there are devices like PC or the PC or your phone that is connecting, they also have their own MAC addresses. Now, so these are like, every manufacturer has their own, distinguished start to these MAC addresses, and these will be unique to those particular devices. This will not be repeated for any other devices. So those are the MAC addresses. Unlike IP addresses, which are provided by you or the ISP in this case, these are provided for those devices, and this will define those particular devices. Moving on, like I said, so what is NATing? NAT or network address translation. The name itself says it's translation. So what it does is basically it lets the communication. So in layman terms, it just allows you the communication between a public and a private address. So that's what is network address translation. Moving on, subnet. Now subnet, again, we will go a little more in detail while we go forward with this course. Now subnet basically is like, now there's a group of addresses that you need. So out of the whole huge range of addresses that we have, we create a group of addresses that is called subnet. So again, we'll see this much better in while we are doing the practicals, as well as while we are going forward with this particular track, we'll see that. Now moving on, now let's see what we are going to cover in this VPC segment. So this is going to be a basic theory track. So let's go ahead and see what we're going to cover in this. So what we're going to see what the VPC is. we're going to see the VPC features. Now VPC has various features. We're going to check that out. We're also going to check out how natting will work. So basically, this would be natting in particularly. We are not going to discuss how it works on a router or anything, but we are specifically going to see a NAT instance or a NAT gateway. That is basically how natting works in an AWS environment. So that's what we're going to cover here. Now then we're going to see security group, what is security group and how it works in the AWS scenario. Then we're going to also work on NACLs, which are network access control lists. So I might be calling it NACL. So so don't be surprised if I'm saying NACL. NACL is only means network access control list. So it is again something that we have to discuss when you're talking about the networking part of it. Then we're going to look at Bastion or jump servers. So I will just give you an idea. It is actually, why is it called a jump server? It is basically an access point to other servers. So this is just a briefing that I'm giving you. We'll see a better explanation when we are doing the practicals, because this is basically to actually access the private, you can say your private instances that you have in the AWS scenario. So if you have any private instances, you can have a Bastion server or a jump server to actually connect to this. So that is what Bastions are used for. And then we are going to talk about VPC peering. Now VPC peering is basically a connection between two VPCs. So you want to communicate between two VPCs, you can do that using this VPC peering. We'll see it in much deeper when you're going to see VPC peering in the coming sessions. So now then again, the other thing is basically VPC endpoints. Now again, we'll see this in the coming tracks. And then there is direct connect. Now direct connect is something basically direct connect can be explained as a direct connection from an office or a house to directly the AWS server. So basically it would act like if it is in the same network. It won't go through the internet. So that's all you need to know now. We'll see that in the coming tracks again. Now moving on, let's see what is, well, let's start and let's first see what is a VPC. So what is a VPC? The full form is basically a virtual private cloud, obviously, that we discussed earlier. So now the definition which is given in on the Amazon website is Amazon Virtual Private Cloud lets you provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. So basically what it means is it's a network area that you are getting. So it's basically a network area that AWS is providing you, and where you can host your infrastructure per se. So what it means is basically like you used to have these data centers where you could physically go and put up your hardware and everything. Here instead everything is provided by AWS, and what you're doing is that space you're using for your own implementation. So it would be a private network for you, which you can choose from that, and that network can be used for whatever purposes you need. So all the infrastructure, underlying infrastructure, all the networking, everything is handled and managed by AWS. But yes, it's something that you can choose and work on. So that's what it is. So and it goes further. You have complete control over your virtual networking environment, including selection of your own IP address range, creation of subnets, and configuration of route tables and network gateways. So what it means is basically that just like how you would use a data center to actually provision all your resources, be it networking, be it the IP address range, all those things, route tables, you can put up internet gateways, whatever you need to do. So that's exactly how you would set up your physical data center. That's how you would be setting up a virtual private cloud. Okay, so I mean, that's now what actually means I've already explained. So it's a virtual data center that is managed by AWS, where you can choose the requirements such as virtual networking and virtual hardware. So that's the short of it. So you have an idea of VPC. What is VPC? VPC is basically a virtual private data center per se, where in which you don't have to manage any of the resources as such, as in you don't have to look after the underlying networking, you don't have to check the underlying hardware that is used. That will be managed by AWS. All you have to bother is about the IP range or the networking part of it, wherein which and that complete control is under you, so you can manage that. So that is what is the VPC. Now let's move on to the VPC features. So the first one is basically it can create. So we had discussed about subnets in a brief. Now I'm not going to go in detail about subnets. I'll probably take that in another track, not in this AWS track. So basically subnets are a group of IP addresses. So now you can choose you can create actually private or public subnets. So basically what it means is you can have a public network or a private network. So public network means you can have access to the internet, whereas private subnet would mean that it will not have access to internet. So it is not accessible from outside. So basically any of the instances within the AWS environment, you can actually go ahead and connect to it. So we had talked about a Bastion or jump server. So that was used for connecting to the private subnet instances. So that is what is the difference between a private and a public subnet. Now moving on, you can actually obviously you can launch EC2 instances into the private and public subnets. Now then you have security groups for instances. Now security groups are basically what handles, I mean for instances, it's like a firewall for instances. So what it does is it's something which handles the communication. So you can block ports, you can do a lot of stuff there. We'll discuss that in detail in the security groups track. Again, network ACLs acts something similar. It is for the subnets though. So again, we'll see that, I mean, it is also for controlling the traffic there. So there is a difference in security group and network ACL. So there are differences there. It's not just about instances and subnets. Why and where would you use it? We'll check that in the security groups versus NACL's track. And then there is internet gateways. Now internet gateways are actually used for VPCs to actually connect. So I mean it allows the instances in say the public subnets to connect to the internet. Now by default there would be an internet gateway. So when you in a default VPC, whenever you create your account, every region will have its own subnets created, and you can actually connect to the internet directly. Now we will try creating a completely new VPC, and we'll see how that builds up. So these are the features of VPC. Now this is something that we are going to do. So this is going to be a setup that we'll be going to do. So basically you will have a region right here. So you will see that there is a region, that is the whole region, and within which you will create your VPC. Now the VPC will connect to the internet using the internet gateway. Now there is a router, that is the AWS router that you will be using. Now there will be a network ACL which will allow the connections to the public and the private subnets, and you have security groups within those subnets which will allow for particular instances. Now for particular instances, if you want particular rules, that will be handled by the security group. So this is what you're going to do. I mean this is how we are going to do it. I'm just skipping this for now. Now let's first discuss about the NAT instance before going forward. So what is a NAT instance? So what the NAT instance does is basically it allows you to I mean NAT instance is an instance that we create which is used for, now there is NAT gateway and NAT instance. NAT instance was something which was there prior to NAT gateway. So NAT instances allow you to actually do what the NATing how the NATing is done within your router. So NAT instance would be like how if you need to connect to the internet and you don't want it to directly have a internet connection. So what you can do is instead of connecting it to the internet gateway, you can allow it to have internet access through the NAT instance instead. So that is what the NAT instances would do. So it has to be, obviously it has to be placed in a public subnet, otherwise it will not have access to the internet. The next part would be it needs source or destination check enabled. So when we'll be creating this in the practical lab, you will see why it needs that. I mean, it would require this to actually work as a NAT instance. It is a setting for the EC2 instance for that matter. So the traffic can be supported by using a bigger instance size. Now, what it means is basically now if you have a NAT instance for like 2 or 3 EC2 instances to connect to, it would be fine. But the problem is when you have more number of instances and your NAT instance has a very small size, what happens is it won't be able to handle the traffic. For the traffic to be handled, it needs to be a bigger instance size. So if you are using, I mean, I would suggest not to go for the NAT instance because it's an old technology, and basically you will have to manage that EC2 instance. And if that EC2 instance goes down and you have a lot of instances actually connecting through this particular NAT instance, it would be a problem. So you will have to build that again, until that time all the instances that are looking at this particular NAT instances for internet connection would lose connectivity. So instead, you should be using NAT gateway. But yeah, so this can be used for, I mean, if you increase the size, yes, the traffic can be better. We can actually go ahead and create a high availability like we do for EC2 instances. So what I was saying, if one NAT instance fails, you can definitely go for another NAT instance. I mean, basically a high availability infrastructure can be created. That is basically if one goes down, the other will automatically spin up, and every other instance that is pointing to this particular NAT instance can, I mean, will point to the new instance instead. So that can be created, but again, like I said, so this is something that you have to do on your own. Now, and the biggest problem would be that because it's an EC2 instances, it will always be behind a security group. So this is something which is particularly a nuisance for a NAT instance, because it will be behind a security group and you'll have to manage everything that is there for that security group and everything. Any change that you do, I mean, some admins by chance does something to a particular security group that is related to this NAT instance, it would mean trouble. So definitely something that you should avoid doing. So what is the solution that AWS came with a future update was a NAT gateway. Now a NAT gateway, there is one NAT gateway that is allowed per availability zone. That is something a limitation for the NAT gateways. But then again, it is, I think it should be good enough because it is managed by AWS, so it should not be a matter to you. So it is redundant in an AZ, and you don't have to worry about the redundancy, because if there is within an AZ, if you create if there is a NAT gateway created, it would be redundant. So if there is no issue of failure there, then it gives you it gives you a much higher throughput of 5 to 45 Gbps, and it will be managed by AWS itself, so that throughput will be managed there. So you don't have to worry about that. And one of the things that I was saying, so when you're creating an EC2 instance compared to an NAT gateway, there is no patching required, because like I said, the underlying infrastructure is handled by AWS. So the patching and everything for a NAT gateway will be managed by AWS. And when it is an EC2 instance or a NAT instance, that means the whole thing about patching, administration, everything you have to manage, which is not the case with the NAT gateway. Again, and this is because this is like a service here, it is not associated with a security group. So it is not behind a security group like NAT, the NAT instance. So you don't have that limitation as well. And basically, what best practice what is used for a NAT gateway is always create a NAT gateway per AZ and let resources use that NAT gateway for the same AZ. So instead of using a NAT gateway for another AZ, you should use that particular NAT gateway in that particular AZ itself. So that's the best practice what AWS tells you to do for a NAT gateway. So let's start with security group now. For security group is the first line of defense, and in the sense you can actually control how the EC2s can be accessed. So this would be the first place that you can restrict that. So security group is that at the instance level. Here by default all inbound traffic is blocked, while all outbound traffic is allowed. It is stateful, which means that inbound and outbounds both need not be changed. If you do change an inbound rule, it is automatically seen as done for the outbound rule as well. So you'll see that in the practical session, we'll see how it works, the inbound and outbound rules being separate and all. Now, you can specify allow rules but not deny rules. So that is something, it's a restriction for security groups. You can actually allow certain things. So like I mentioned, by default, all the traffic, inbound traffic is actually blocked by default. So there will be only allow rules here and no deny rules can be there because everything is already blocked. So there would be only allow rules here. There can be under a particular security group. So now if you have a security group, say, which allows you to have access to, say, SSH and HTTP port, so basically port 80 and port 22. So if you only have a security group doing this and you, it makes sense that can be associated with many instances because you creating the same rules on multiple security groups and attaching them to the attaching those instances to separate security groups makes no sense. So security group allows you to have many instances in a single security group. So and if you want per se, if you have an instance which requires, so there is a security group you have created for basic HTTPS, HTTPS access as well as SSH access. But now you require this particular server to have some other ports open as well. So which are unique to this particular instance only. So say it's port 8080 or 8081. So you want these ports to be open. So instead of adding those ports to the same security group, you can create a separate security group which will have only access to these ports and these ports on particular IP addresses. You can create those security groups which are unique, and then attach basically the web security group that you created, that is the HTTPS, HTTP and SSH connection one, as well as the unique security group you created now, and both of them to this particular instance. So that can be done. Now, one more problem with this particular security group feature is that you cannot block IPs from this. So you can actually block particular ports from accessing, ports being accessed, but you cannot say that, okay, block this particular IP. You cannot do that. So that is something which security groups cannot do. Now let's move forward to NACL. Now network access control list. So these can actually go ahead. So let's start with the first thing that security group cannot do. So security group could not block IP addresses, whereas NACL can. Now each NACL can have multiple subnets associated with it, but not vice versa. What it means is that NACLs can have multiple subnets. So this particular NACL, when created, it can have these 2 or 3 subnets associated with it, but every subnet can have only one NACL. It cannot have associations with multiple NACLs. So that's why it is have multiple subnets associated with it, but not vice versa. Now this is the rule. You'll see how this works in the practical session. So the lowest number will be the highest or the first preference. What does this mean? So this means that when you have put rules, so whenever you put rules in under NACL, what happens is that basically it will take it as the lowest number is highest preference. So if you're starting with 100, so if you are starting with 100 and then you go, usually AWS tells you to go with an increment of 100. So if you go for 200, 300, so 100 would be the highest priority, and first preference. So if you block everything in 100, then there is whatever you put in 200, 300, it will not even matter because it is not going to check all those. It's going to check the first or the lowest number, and it is going to check that as the first preference. Now in NACL, unlike security group, this is stateless. So you can have separate inbound and outbound rules. So these are totally separate. So just because you have set something in the inbound rule, so if you have allowed a set of IPs or set a particular range of ports to get access, it doesn't mean that it will be automatically done in the outbound rules. You have to go ahead and check that out. Every subnet is associated with a NACL. So this is again, now we have already seen this where in which, so I mean basically what happens is that every subnet that is created in the VPC, that will be associated to NACL. So now the next line, I mean I'll go with the second one as well. So it is not explicit, if not explicitly associated. So basically whenever you create a subnet, it gets automatically assigned to an NACL. So it will be assigned to the default NACL of that VPC. So if you are going, you can actually take that particular subnet and tell it to associate with another NACL. But if you are not done that, if you have not explicitly given it, I mean orders to actually go and connect to another NACL, it will be automatically associated with a default NACL. So that is something how the association works for the NACL and subnet. Now default NACLs allow all inbound and outbound traffic rules. So the default NACL that is created with the VPC will always allow everything. So it's basically an unsafe thing. This is the second line of defense, but it is still going to be unsafe if you are going to allow everything in and out. So you will have to go ahead and change those rules as per the requirement. Now custom NACLs on the other hand denies all inbound and outbound traffic by default. So unlike the default NACL for the default VPC, the custom NACL, I mean basically when you create a new NACL, it will always deny everything. So for basically, if you want any access on this particular NACL that you create, you will have to go ahead and create those roles to actually do the other way around. So it will have accept and denies. So a default one will have all allow, whereas the custom one will have all denies. So if you want to make that change, you can make it in this manner. Now let's talk about the Bastion or jump servers. Now the Bastion or jump servers, I had given you a brief idea in the start of VPCs, what we're going to cover in VPCs. So Bastion or jump server, I mean these are basically hardened servers. So basically these would be EC2 instances which are hardened. Now what does hardened mean? Hardened means that they will have all the patches, required patches, it will have all the security. So if you have like antiviruses, you will have I mean basically all blockades, unwanted softwares are removed, everything, that it will be a very difficult machine to penetrate by hacking or anything. So this is what is a Bastion server. So instead of doing this for all the servers, what you can do is make your other EC2 instances which you don't want access from the outside world as private instances, and then you create these hardened servers to actually get to those servers. So what will happen here is that if anybody is looking from outside, so any person who is trying to access your network, they will always be only seeing your hardened Bastion server. So they will see this Bastion server, they will try to penetrate it, but because it's hardened and it is secure, they will not be able to get it. So your even if it is the unsecure servers which are on the private network, they will never be accessible from the outside world because they are private EC2 instances. So this Bastion server can be used in that manner. Now used to accessing SSH or RDP an instance in a private subnet. So this is what I said. So basically these are just servers used to go ahead and access any of the servers in a private subnet. So this is basically used for an SSH or RDP to a particular instance within the private subnet. So this is like a gateway to your servers in the private subnet, you can say. Moving on, let's move on to VPC peering. Now VPC peering, like I said, it is a connection between two VPCs. So connects one VPC to the another. Now can peer across same region. Now earlier there were like limitations of within the region only now, but now it can peer across same region, different regions, or even across accounts. So it has given you a wide range of access. So basically VPCs within the same region, different regions, or different accounts can be done here now. Now EC2 instances across VPCs act as if they are in the same private network. So what happens when you do VPC peering is that two VPCs are joined together. I mean, they would act as if they are a single cloud or a single network per se. So they will never understand that they are two different accounts or two different regions, but they will act like a single network. Now, no transitive peering or star configuration. What it means is that, so we'll take up this in the coming slide because I will show you what it means really. So let's go ahead and check that out. So now when VPC peering happens, now you'll see that now VPC 1 is connected to VPC 2. And let's go ahead and see if, and VPC 4 is connected to VPC 5. This doesn't mean that this cannot be like, I mean, if there is no direct peering here with VPC 5, you cannot have like, okay, VPC 1 is connected to VPC 4 and VPC 4 is connected to VPC 5. That doesn't mean that without this peer, this will be connected. So that is what is no transitive peering. Now let's see the restrictions for VPC peering here before going ahead. Because these are certain things that people have a lot of confusion with. Why is it used and all? So there cannot be an overlap of IP ranges in the two VPCs. So basically, yes, they can seem like within the same particular network, but you cannot have overlapping IP. So yes, obviously that is going to be a trouble, because if you have the same IP ranges, it can be it can be a problem, right? So just think about it. If I have a range of 192.168.1.0/16, that is the range that I'm using in one VPC, and another VPC comes up with the same ring. So when these two do VPC peering, and if there is an overlap, there would be an actual overlap between these two VPCs IP ranges. What would happen? The moment these two get peered, what will happen is that there would be a lot of address conflict, and there would be literally a breakage in the network. So that should be avoided, and that's why if there is an overlap, you cannot go ahead and do a VPC peering. Now, no sharing of edge routing or internet gateways across VPCs. So again, so it's the same thing. So the edge routing and internet gateways cannot be used. So I cannot use a VPC 1 internet gateway for the VPC 2 EC2 instances, because this is just kind of a virtual private network that is getting created. So you cannot use the internet connection of another VPC. So you cannot use the internet gateway from another. So same with the edge routing as well. Again, similar to that, there cannot be any NAT routing between the VPCs either. So you cannot similar case for what we have the internet gateways. You cannot actually tell one of the EC2 instances to connect to the NAT instance or the NAT gateway. You cannot have a NAT route to that particular so if you have a NAT gateway or NAT instance in VPC 1, you cannot tell the VPC 2 EC2 instances to have a route to that. You cannot do that. Now it cannot resolve private DNS values across VPCs, obviously, because these are actually different networks. It is just a feature in which it allows you to connect to make it believe that it is the single private network. Now, no cross-referencing of security groups between, again. So it's very similar. So all the features that you have in one VPC, you cannot use it. Most of them you cannot use them on the second this thing. So it will act as if it is in the same network, but these features will not work like NAT, Internet Gateway, security groups, DNS values. These all cannot work across the other VPC. Okay. And now let's continue with this. Then again, VPCs can be of same or different AWS accounts. So this we have already managed. So earlier it was not allowed. Now it is allowed. Same or different AWS accounts. It's fine. Anything is fine. Same region, different region. It can be of the same account, different account. All this is possible. So that's also possible. And again, routing needs to be done after peering. So basically for the routing to be completed, basically the peering to be completed, routing needs to be done after peering. So that is something we'll see when we are doing a VPC peering lab. Now traffic flow is through private network. So there is, like I said, so there is only an internal traffic flow. So that's why the flow is actually in a private network, and that is the reason why you cannot use internet gateways, you cannot use any other external routes, and security groups and all are not getting used because we are using a private network here. So that basically VPC peering is actually using this private network to route route between both the VPCs. We'll see that in much more clarity when we are looking at the labs. Moving on, VPC endpoints. Now, basically, what is a VPC endpoint? So it's an access for instances to supported AWS servers without traversing the internet. What does that mean? So what it means is basically now, for example, I've created an EC2 instance, and when I'm trying to actually go and connect to any of the resources, not through the console, but even when I'm trying to access it otherwise, through the AWS CLI, what happens is mostly what it does is it tries to traverse the internet and reach the services. Now, I do not want to do that because it's one, it is basically a slower process, and two, it's sometimes not safe to do that. I don't want it to traverse through the internet. I want my request because both my resources are on the AWS platform. Why would I want it to go through the internet? I want it to go through the particular, directly to the service, not through the internet. So that is where the endpoints come in. There are two types of endpoints, which is interface and a gateway endpoint. Now, interface endpoints support a lot of services. There are a plethora of services which are managed under the interface endpoints. We'll have a look at it when we look at it in the, when we do the practical sessions, we will see that. Now, again, interface endpoints is not something that we're going to create, but you'll see that there are a plethora of services which are handled under it. We will be looking at probably a gateway endpoint support. Basically the gateway endpoint is supported for S3 and DynamoDB only presently. But since we will be using S3, let's check out if we can create a gateway endpoint in the practical session. So these are the two, interface endpoint and gateway endpoint are the two VPC endpoint solutions that we'll be looking at. So like I said, so it's basically allowing your AWS instances to connect to supported AWS services without traversing the internet. So that is what is VPC endpoint. Now let's talk about direct connect. Now this is the last topic under VPC that we'll be covering. Again, now this I will not be doing a practical session for in direct connect because direct connect is a very costly affair, and to be very frank, there is no requirement for me or you right now to actually check out direct connect, but it is pretty straightforward. So I'm going to explain it with a diagram. So let's go ahead and check that out. So now, first of all, let's see what are the features of direct connect. So, and what it is, it directly connects your data center to AWS. Basically, it can be your data center or your office, whatever it is, to the AWS, directly to AWS. It's a stable and secure connection. So it is basically a connection between your ISP and basically there's a connection that is extended by AWS, and there's a last mile wherein which you will have your ISP provide you a dedicated line wherein which you can connect to the AWS services. So there would be a dedicated line. It would seem like there's a dedicated line from your end till the AWS data center. So that is the direct and this would be stable because it's a private line. So you are getting a private line you can use. So there is no other traffic here. You are the only user on this line. So it will be stable and secure. Again, now it can be used for higher throughput workloads. Exactly. So because if it's going and traversing through the internet, or if it is not a dedicated line for you, what would happen is that there would be a lot of interruption, there would be a lot of hops, and basically before this data, before it reaches the destination. So if you're sending a data, say if you're doing S3 upload, for instance, what would happen in the case of case without direct connect is that it will go for multiple hops before it reaches the S3 bucket. So and it would be a time consuming activity. Whereas when there's a direct connect, according to the throughput of the line that you select, you can have that complete throughput used for workloads. So that is what direct connect can do for you. Now let's go ahead and see how it works. So now this is, say this is my data center now, and this is AWS cloud. How do I connect from this to this? So usually I use the internet to traverse. So now what would happen is, like for direct connect, what they do is AWS puts up another basically they have the data center where there is an AWS rack or cage, and they allow the client to have their own rack or cage over there. What's a rack or cage, you ask? So rack or cage is basically whenever in a data center, for a data center to actually host servers and infrastructure, they have say it's a storage unit for these servers. So you will see that you can actually put up your servers within these racks or cages. So they will allow you to do that. So there will be, you can put up your servers over here, whatever you require here, and AWS will allow you to put up. AWS will have their own infrastructure within the AWS rack or cage. Now this will be the direct connect location. So what will happen here is, now there is going to be a cross connect cable. What is a cross connect cable? Basically it is a cable that is going to connect to the AWS rack or cage. So your rack is directly connected by a wire directly to the AWS connect. Now this last mile is a dedicated line that you are choosing from the your data center or the client data center, where for whatever solution you are using. This would run into your rack or cage, and here there will be a cross connect to the AWS rack or cage, and then this AWS rack or cage is actually directly connected to the AWS backbone network to the AWS cloud. So this would be the main area where the AWS hosting is done. So this is how the connection is done on direct connect. So it's a pretty straightforward thing. So there's a last mile which is connected to your rack or cage, wherein which from where you will be connecting it to the with a cross connect cable, you will connect it to the AWS rack or cage, and from there it is connected to the AWS cloud hosting using the AWS backbone network. So that is about the network connect. So that's about it. That's all for this track. Thumbs if you liked it. Do subscribe to my channel if you haven't. Click the bell icon for updates on new uploads. For more such content, keep watching Tech Mozart. Thank you, bye, and see you in the next one.